Hello, good day. My name is Mikail and this is Juan Aristizabal, and our project is the magnetic train system. Our objective is to explain the different developments that have occurred in the magnetic rail system.
So to begin with, we're going to explain how magnetic trains work. Basically, they use the force of electromagnetic fields to levitate above the railway, and therefore they reduce basically they eliminate the friction between the tracks and the wheels of the train, and making them more efficient. So electromagnetic fields basically is an interaction between two bodies that have a net charge, either positive or negative, and those fields are generated when their chargers move from one body to the other one, and therefore they create a force which is used for the magnetic trains to levitate them, and that's how they move.
Okay, so the magnetic railing system, they basically use these materials or metals known as superconductors. So what are superconductors? Superconductors are materials which can conduct and carry an indefinite amount of electricity with no resistance nor with any energy loss. No energy is lost until when critical temperature is achieved. Critical temperature is basically the temperature at which a material becomes superconductive. There are two types of superconductors, type 1 and type 2 superconductors. The main difference between these two types of superconductors are the fact that type 2 can be penetrated by a magnetic field, whereas type 1 cannot. So an example of type 1, for instance, they can be found in everyday devices such as microchips, such as wires. These are normally materials such as lead. And for type 2, these are materials such as copper, for instance. So there are two types of electromagnetic train systems. There's the electromagnetic suspensions, or EMS, or the electrodynamic suspension, known as EDS. So first we'll discuss electromagnetic suspension. This system involves both levitation and propulsion. Levitation is achieved by the constant altering of the strength of a magnetic field produced by electromagnets using what is known as a feedback loop. So looking at this diagram right here, how basically how this works is the conductors under the guideway, they attract what are known as the levitation magnets from the train, and that attraction that causes levitation. Whereas on the side where you see the guidance magnets, that sort of balances the train, and it prevents the train from actually touching the guideway or the rail, and this in turn leads to propulsion, because it tends to guide along the pathway of the railway.
For the electromagnetic suspension, electrodynamic suspension, it uses a little bit of a different type of magnetic field. So we have two magnetic fields, which are one positive and one passive. The positive is normally located on the train itself, and the passive is located in the railway. The way they work is that the interaction between the two magnetic fields occurs at high speeds. So these type of trains require to have wheels to be traveling at lower speeds. They are also more stable because they don't require computerized software to control, to prevent them from touching the railway. As for the other electromagnetic, they are very unstable. So this is possibly a better option for an electromagnetic train. So basically right now in service there's only one train in Japan called the LO series Shinkansen, and it travels from Tokyo to Osaka, and it reaches speeds of 310 miles per hour, and they use the electrodynamic technology for the development of this train. In terms of our design, so we wanted to see our prototype will be an electrodynamic train, and we want to achieve speeds of 150 miles an hour using an evacuated tube which in addition to eliminate the friction between the wheels and the railway, we will also eliminate the drag reduced by the air resistance. So we'll be a more efficient, we'll be more able to reach higher speeds, and we'll be able to transport passengers from Miami to New York in about 4 hours, which will be a lot less time than if you were to take an airplane. The train will also have to, because it is going to be a electrodynamic system, it's going to require to have some kind of wheel system for when traveling at lower speeds. So our design includes a retractable wheel system, just like they use it for the airplanes, that once the train reaches the needed speed for the train to levitate, it will just retract the tires and therefore increase the efficiency of the aerodynamics of the train.
So in conclusion, as you may have noticed from our proposed design, we went along with the part of the EDS system. As we decided that was the preferred system of the two. It is more efficient and more effective. And for our design, and as we discussed, we expect a 70% reduce in air resistance, and we also expect it to attain greater speeds of up to 550 miles per hour. And that is our project and our presentation. Thank you.
Thank you.